Everybody, welcome to today's Kubernetes Clinic, how to run Kubernetes securely and efficiently. Today's featured presenters are Joe Pelletier, who's a VP of Products, and Robert Brennan, who's our Director of Source. Today's session will be in listen-only mode. If you do have a question, please submit it in the Q&A tab in the lower right-hand corner of your screen. Robert and Joe, take it from here.
Thanks, Dave. Nice to be with everyone today. Today, we're just going to go through a few items as we talk about how to run Kubernetes securely and efficiently. We'll understand why organizations choose Kubernetes and some of the challenges, moving to cloud-native technologies, as well as the technical implications of what security and efficiency are in Kubernetes. We'll also talk a little bit about policy and governance and how that can help and enable speed to market, but also set the right guardrails for teams. And we'll give you a quick demo of a Fairwinds product. So let's just take a step back and talk a little bit about how software development is changing. And we know that with the adoption of containers, software packaging is increasingly shifting left. And that means, depending on your organization, developers are going to be taking on responsibility for the containerization of applications. They may also be responsible for parts of the Kubernetes configuration. And as that process shifts left, developers need to be enabled to make the right decisions. We also know that container adoption is also growing very quickly. And by 2023, according to Gartner, 70% of global enterprises will be running 2 or more containerized applications, and that's up 20% from 2019. And finally, kind of as container adoption grows, we know that Kubernetes is becoming sort of the de facto standard for running containerized applications in production. And so even more and more, we're seeing Kubernetes going from what is kind of considered an interesting technology that companies are testing out to many companies running Kubernetes in production and scaling up their applications, with Kubernetes as the main container scheduling platform. So a lot of this is really being driven, by the adoption of cloud native technologies. And really why companies are adopting cloud native technologies is so that they can, really deliver speed to market. These are just some pretty high level stats that you can expect as companies move from traditional development processes to cloud native. And really, at the end of the day, for businesses to compete in today's marketplace, they have to be able to ship new features and meet customer needs where they are. And increasingly, that's obviously through software. So with container technology, companies can really automate their parts of the development process. They can also fix issues quicker, and they can get better control over how they get product to market. But with those moves to containers and Kubernetes, there are some challenges that can emerge. At the end of the day, there's really kind of 3 key challenges that a CNCF survey highlighted for us about a year ago. And the first one is really around that cultural change to moving to cloud native technologies like containers and Kube. This often means changing the development process, but also potentially shifting some of that responsibility more to teams so that they can embrace service ownership and really own what they basically, they'll be responsible for the code that they write in production. Along with that, there's also new security considerations. With cloud native technologies, we're dealing with a whole new different sets of concepts and technical considerations that really change how you think about security, especially when you run containers and Kubernetes technology in the cloud or using it in a multi-cloud or hybrid cloud type scenario. The other thing that we find is that the complexity around all of this is really something that causes security teams to have to take a step back and really understand, what are some of the new threat landscapes with cloud native technology. But even with development teams who are adopting this, there's new complexity that comes into play there as well. It's more than just technical complexity, it's also organizational complexity. And we'll talk about how this affects different roles and personas. So let's dive in to that first point, which is really the cultural shift and the changes in the development process. First, adopting this technology means introducing kind of new technical decisions that have to be made along the way. And depending on the organization, there's going to be some shared responsibility between dev and DevOps teams around which parts of the technology are being owned or maintained by those folks. So if we think about developers, they may increasingly be moving their applications to container technology. And to get it to run in Kubernetes, they need to also be able to own the configuration and define how that configuration is set up and implemented. At the same time, SRE and DevOps organizations are being tasked with building out, platforms as a service internally so that they can build, reliable and scalable base infrastructure. And that often means being able to have to select, certain types of add-ons or supporting technologies that drive the Kubernetes cluster. And finally, we know that security is a stakeholder in all of this. They often, have to spend a lot of time coming up to speed on the latest technology implications. And this translates into a need around visibility. Security needs to be a partner with dev and DevOps. And so they not only have to come up to speed on the new changes, but they also have to get, visibility into where those risks may be. And so this is really just a high level idea of the types of implications when you move to Kubernetes and containers, the new types of questions that emerge. When it comes to the actual container technology itself, understanding what known vulnerabilities or CVEs are in those containers become important. And when it comes to the configuration, there's a number of different ways that Kubernetes can either be, configured to be insecure or configured to run in a way that is not reliable or not efficient. And so a lot of these new decision points are introduced in the process. And in fact, a recent article highlighted, and this is an article from last year, highlighted that 69% of reported Kubernetes incidents were actually related to misconfigurations. And so we know that this is the top area of concern for lots of organizations, especially when cloud native technology is being adopted and shared between dev, security, and ops. And so you have to really have that collaborative environment in order to successfully deliver these products to market. The other, complexity factor that comes into play is really the organizational complexity. There's different personas involved along the way, and they each have sort of different questions that have to be answered. So let's put ourselves in the shoes of a developer first. A lot of times, developers are being paid just to write code, build new features, and ship their application to production. And so they need to know just enough around Kubernetes and containers so that they can continue doing their job well and getting applications out to customers. This might mean, that they accidentally over provision or give too much memory and CPU to the application at the time of deployment because, their time is of the essence and they don't know enough around how to configure Kubernetes properly. And at the same time, the site reliability engineer or the SRE, they need to make sure that the application is reliable and stable. They need to make sure that the applications they're getting from development have the right best practices configured, and that they're also ensuring that they have things like health probes and health checks enabled so that the applications can run reliably in production. And finally, security is looking at all this and saying, these are all new technologies with all new security considerations in play. They need to know about things like, are we running vulnerable versions of our containers, or have we configured these applications to be secure? So a lot of times in these environments, you need to be able to build processes and guardrails in place in order to meet the needs of multiple personas. We're going to go and now share a little bit of some of the technical considerations and give you examples of where these types of issues can technically occur. And I'll turn it over to my colleague, Robert, to kick that off.
Thanks, Joe. So there's a few different sort of layers in the stack where you're going to want to look out for these types of misconfigurations. At sort of the highest layer is the container level. So this is where your application is packaged up with an operating system, certain files and applications. This is where you really need to be on the lookout for, say, known vulnerabilities being packaged up, whether that's at the operating system level or inside the applications that are being put into that container. Another layer up towards Kubernetes is going to be the deployment configuration. So this could be some Kubernetes YAML or a Helm chart, something like that. And you really need to watch out for basically misconfiguration at this level. You want to make sure that, say, CPU and memory settings are being set, that you're setting liveness and readiness probes for your application, that there aren't extra security permissions being added to those deployments. This is really everything that wraps the container and tells Kubernetes how to run it. And then at the highest level, we have the Kubernetes cluster itself, which can be misconfigured, say, to be publicly accessible on the internet, which has led to some pretty famous security issues. You have to make sure you have role-based access control in place. There's all sorts of add-ons that are being stuck in there to do things like ingress and certificate management, making sure those are all up to date. Really making sure that the Kubernetes cluster itself is properly configured is super important. But today we're going to really focus on these left two columns, which are a bit closer to where the developer lives. So the containers themselves, and then the deployment configurations that wrap those containers. So at the configuration layer, there's a lot of security settings that go into the Kubernetes configuration. You can see on the right side here, highlighted in red, we have the entire security context for a sample application here. And in this particular example, we're doing a whole bunch of stuff that is very insecure. You can see we've allowed privilege escalation on this container. We've created a writable file system. We're allowing it to be run as non-root. We're adding a bunch of capabilities to the container that it doesn't necessarily need. Most applications aren't going to need to add additional security to their application. They should run fine with the default configuration or even with a pared down security context from the default. When you add extra security or extra capabilities to the container, you are basically giving this container extra access to the host node that it's running on, which could allow an attacker, if they got access to this application, say through some kind of security injection issue, they would be able to escalate their permissions to other workloads running inside the same cluster. So this security context, if it's set properly, should really isolate this container from everything else running in the cluster, so that if an attacker gets access to this container, they're basically walled off from being able to do anything else to the other applications running inside the same cluster. So it's super important to make sure that this security context is set properly. Another issue that you really need to be on the lookout for are vulnerabilities running inside your container. There are a lot of great tools out there, both open source and commercial, for scanning containers for known vulnerabilities. Basically, they keep a database of all the vulnerabilities that are known and cross-check them against your actual containers. It's super important to basically scan your containers, as they're getting built, maybe as they get checked in or pushed into the cluster. But that's really not enough, because at any point, a new vulnerability could get announced, and that container that you've already scanned might suddenly be known to be vulnerable. So making sure that you're continuously scanning these containers or continuously redeploying them so that they do get rescanned is super important. If you have a container that's been running in your cluster for a few months and hasn't been rescanned, there's a good chance that it's running a known CVE at this point. So make sure you're doing container scanning on a continuous basis. Another issue, as we went into before, is this issue of basically the principle of least privilege. Again, making sure that your containers are not being granted a whole bunch of extra security permissions beyond what they actually need, and making sure you're paring back the permissions that are set by default. Really make sure that each of your containers are isolated from all the other workloads running in your cluster. Moving away from security and more towards the reliability side of things, setting liveness and readiness probes is super important. These are basically ways for Kubernetes to tell if your application's healthy, if it's crashed or anything like that, and if it's ready to serve traffic. This is, these are settings that Kubernetes, if you don't set them, Kubernetes isn't going to complain. It's just going to try and do its best with the information it has. But it really makes it a lot harder for Kubernetes to do its job to, say, self-heal or have zero downtime deployments. If you don't set these, Kubernetes has no way to tell if your application's healthy, and so it won't. If your application crashes, it won't, kill that pod and start a new one. Or if you're releasing a new deployment and it starts up a new process, but say it's still waiting to connect to the database or still starting up. If Kubernetes doesn't have a readiness probe set, it'll start routing traffic to that pod that's not ready to serve traffic, and you're going to have some downtime during your release. Another big issue we see is inappropriate resource requests and limits, or these not being set at all. Again, Kubernetes isn't going to complain if you don't set your CPU and memory settings. It's just going to do its best to make sure your application has the resources it needs. The problem here being, if you don't set any kind of limits, if you have a memory leak or something like that, Kubernetes isn't going to think your application's misbehaving, and it's just going to keep giving it more and more memory. It could starve other applications for memory. It could lead to huge cost overruns, that sort of thing. So making sure that you've set CPU requests and limits is super important. But it's also very important to make sure that those requests and limits are set to sane limits. So you can see here on the right, a developer has set their application to use 4 CPUs and 20 gigabytes of memory. It's a good chance they don't need all that much CPU and memory, and that those should be set a lot lower. Often when folks are told, hey, you need to be setting CPU and memory, they'll just set them to something very high because they don't really know what to set them to, and they want to make sure their application doesn't crash. And having more than enough memory is it's easy to guarantee your application's not going to crash. But this could lead to huge cost overruns. If this application, for instance, only needs 1 gigabyte of memory, then we're spending 20 times as much money on the underlying infrastructure than we actually need. So just to recap, there are a couple examples we gave here that would lead to increased security risks, in particular having containers that are running known vulnerabilities or over permissioning those containers to grant them too much access to the underlying nodes. Leads to a lot of additional security risk. And then in terms of application reliability and downtime, making sure those liveness and readiness probes are set. And in terms of keeping your your costs in line and manageable, making sure that you're setting CPU and memory settings is very important.
Thanks a lot, Robert. That's really helpful examples to get a sense of where do some of these configuration driven issues emerge, and what to do about them as well. I think one of the areas that we've heard from our clients is there are ways to get in front of these types of challenges, so that one, you are shifting that feedback earlier to the development teams who need to get the information at the time that they're making these configuration decisions, and give them the information in a way that's easily consumable so they can avoid these types of issues. And at the other end of the spectrum, also help security and operations teams ensure reliable and secure infrastructure. And really the category that's starting to emerge to help address this is really the Kubernetes policy enforcement area. And the goals of Kubernetes policy enforcement is really to help at the end of the day enable speed to market without sacrificing the security, the efficiency, or the reliability of Kubernetes infrastructure. And so you can help prevent common misconfigurations from being deployed with policy and governance, and you can also enable compliance with these this new category, and then the tooling associated with this category. At the end of the day, too, this also helps unify really kind of DevSecOps. You can create guardrails that prevent the challenges, but again, give the feedback at the right times where developers and service owners are making these decisions. So just to kind of frame that up a little bit, what we've seen a lot of our clients do is apply policy and governance tooling in 3 different areas. If we start at the far left, really at the time of a Git check-in, or at the time of when a developer is making a Helm chart change or a deployment change, they're checking that in typically into a Git repo that is storing their infrastructure. At this time, you can do things like container scanning, or you can also validate that Kubernetes configuration to make sure it is aligning with best practices. These are pretty quick analyses that can give feedback in real time and help those developers avoid mistakes that may manifest, if they ignore them and don't address them and go into production. So this is really the earliest point at which you can kind of give that feedback to the user. The second point is really at this point of admission, and this is sort of like the last mile before an application gets into Kubernetes. We all know that continuous deployment is really important for getting to that speed to market, and container technology and cloud native technology is really great at enabling continuous deployment. But there are times where you want to make sure that certain types of configurations are being enforced, and this is really again to help drive whether it's a security requirement or enabling kind of reliability and efficiency. And so we help our clients define these policies and implement these policies so that they can really kind of put guardrails around the time of deployment. The third area is really the runtime continuous monitoring. You may have already been running Kubernetes for quite some time. In fact, we're seeing lots of companies now have been running Kubernetes for 6 months, a year plus. And you want to understand where are some risks already around the existing deployments, or where can I improve the reliability or efficiency of my workloads? That's an area where having a solution that can continuously monitor the workload configuration and also the vulnerability posture of your workloads becomes really key to kind of getting that visibility. Another area where we see continuous monitoring being really helpful is really kind of bridging that gap between security and operations. A lot of times we're hearing about security teams who have to go to operations ad hoc to ask a question about the security of a Kubernetes environment. And this tooling in this space can really help you give that single pane of glass. So a lot of the examples that Robert shared just a few minutes ago can also be transferred into policies and guardrails. And these are just some example policies and guardrails that we help our clients with all the time. One common example, which is really just related to consistent best practices, is making sure at the time of deployment your workloads have the proper labels set so that who is the service owner for that application, or are the labels set up correctly so that Kubernetes knows how to scale that app, etc. Similarly, making sure that you also have CPU and memory requests set. These are kind of really important best practices so that you're running your workloads efficiently. But frankly, a lot of the examples that Robert shared can also be configured as policy and help you prevent these types of challenges. So what I'll ask Robert to do is help us walk through a couple of the different options available, right? At the end of the day, there's really kind of 3 different options and routes you can take to implement policy and governance solutions. And I'll have Robert talk to us a little bit around kind of the first choice, which is building your own internal tooling.
Yeah, thanks, Joe. So building your own tooling to do stuff like policy enforcement can be very tempting. It's a really fun problem to tackle, as I can tell you, as somebody who's built a lot of this type of tooling. It definitely satisfies those engineers who really want to be creative and build their own tools and things like that. And the other nice thing is it can be fully customized to your needs. Anything that you want, any particular policies you want to enforce, you can do it if you want to spend the time actually, doing that engineering work. The downside is it really is a full-time job. You're going to need a lot of effort from the engineering side, both in terms of building the initial implementation, as well as actually, maintaining it over time, adding new checks, things like that. It's also a very undifferentiated work, right? This is stuff that has been done over and over by different organizations. It's been done by organizations that specialize in it. So, you're kind of reinventing the wheel a little bit. And it's not really going to add to your competitive advantage unless you're, a Kubernetes security company or a Kubernetes configuration company. There's also a lot of unknown unknowns when it comes to Kubernetes, and the best practices out there are always evolving. So your internal team, unless they are, very seasoned Kubernetes experts, they're probably going to miss certain things that the community is on top of. And so, being able to leverage external projects, whether that's open source or commercial partners, it's really going to help you catch those things, ask those questions that you might have not thought to ask yourself. Another potential strategy here is to use open source tooling to check for these things. There's a lot of open source tools out there. Some are focused on security, some are focused on best practices, some are focused on helping you define your own policy. Again, this is easy to customize. You can kind of pick and choose from the giant portfolio of open source that's out there. It does have that advantage of using a third party. Kind of gives you lets you sink into the community's knowledge around best practices and everything there. The cons, though, are one, again, you're going to need to do a lot of R&D to figure out which of these projects to use and which ones are suited to your needs. It can be really hard to operationalize these tools as well. A lot of them are very point solutions. They solve one particular problem well. You could use OPA in order to help you define your own policies. You could use Polaris for best practices. You could use Trivy for container scanning. But now you have all these different all these different tools that run at different points in the development process. They all have different output formats. So it can be hard to really get all the results from these different tools kind of into one place, in a single format, linked into, say, Slack or Jira or whatever systems you're using to track the fixes. Another big issue is it's hard to get support on these projects. Most of them are run by basically a community of volunteers, and they can be helpful in certain cases, and in other cases can be a little unresponsive. So it can be a little difficult to get support in the long run. You may find yourself kind of holding the bag in terms of maintenance and support. The final option is to really use a purpose-built platform, a commercial platform to help you out here. I think having a commercial partner makes it really easy to navigate this field of security and configuration issues and best practices. Because a commercial partner is going to have a lot of opinions. They're going to have seen a lot of different environments, different needs across many different organizations. They're going to be able to hold your hand through this process, dig into the specifics of your organization, what you're focused on, what your appetite for risk is, what your security needs are, what your compliance needs are, where you've had issues in the past, and they're going to be able to make recommendations for how to deploy both open source and commercial software in order to meet your organization's needs. The cons here, obviously, it costs money. You're going to need to figure out how to provision budget appropriately. There are some commercial components involved, even if they do leverage a lot of open source, as most companies in the Kubernetes ecosystem do integrate a lot of open source, whether it's third-party open source or their own open source, which can make it a lot safer in terms of vendor lock-in and things like that. But you do have to consider any potential for a commercial lock-in there.
Great advice, Robert. I think one of the things that we tend to coach clients on is sort of what to look for in different types of solutions, right? I mean, depending on your use case, open source could be a great option, or if you're in a multi-cluster, multi-team type environment, like sort of a lot of medium to large companies might be, sometimes moving to that kind of commercial option can give you more flexibility around and more scalability around addressing Kubernetes policy and governance. Really, at the end of the day, you want to make sure that there's solutions that help you prioritize findings from multiple tools. Like we talked about, security teams are often asking operations teams for some visibility into the Kubernetes clusters, and it's important to have shared tooling in that space. At the same time, compliance is also important for some larger organizations or some regulated organizations, and so being able to get compliance reporting is also key. The other thing too is any solution that you pick, being able to integrate with the systems that you already use, like Jira for ticketing or Slack for chat, things like that are really key, because you're going to want to make this, you want to really save time and make the process efficient for getting the information to folks at the right time when they need it. Finally, like Robert said, getting access to support as well as how to remediation device, that's really where you're going to get some additional ROI because you need to be able to make these decisions sort of at the speed of development. And we all know that container and cloud native technology is enabling businesses to move much faster. So at the end of the day, I think we've kind of talked about a few different business benefits here. Clearly with policy and governance solutions, there's an improvement to security that you can get because you're gaining visibility and also recommendations on how to secure your environment. You can also reduce costs, not only by saving time, but also by setting the right CPU and memory profile for the applications that you are deploying to Kubernetes. A common mistake that a lot of teams make is they don't set this correctly, or they over provision, and sort of what Robert was saying earlier. And that's an area where being able to set the right resource requirements is a key to saving on your cloud bill. And finally, there is a time savings, especially if you can automate the policy and governance problem. Now, Fairwinds has developed some software in this space, and we have a couple minutes left on the webinar where we can give you a quick tour of what that looks like. And I'll be showing you a little bit about Fairwinds Insights, which is our commercial platform for Kubernetes policy and governance, and sort of the different areas that we integrate with. So here in the demo, you'll see that at a very high level, we have our software running on one of our Kubernetes clusters, but we can support a multi-cluster environment. So if you have lots of clusters, you can gain immediate visibility into configuration, security, reliability type risks across the estate. The one example that you'll see here is that we've got a couple different types of findings in our cluster, and one of them is actually privilege escalation. And so it looks like some of our workloads are configured with privilege escalation. And that's typically something that a workload doesn't need unless it's serving up some sort of core system requirement. So the first thing I want to do is make sure I have a process in place where I can help provide feedback to development teams at the time of their configuration changes around where they have made a potential configuration mistake that is violating policy. And you can see here that we have one of our developers has accidentally made a change where they've allowed privilege escalation for this particular Kubernetes workload. And what we're able to do with Fairwinds Insights is do a quick scan at the time of that pull request and provide kind of immediate visibility into the risk of the fact that they've set privilege escalation as part of their configuration, as well as some quick advice on where to go ahead and fix that. So we're, as organizations move to, containers and Kubernetes technology, they have to kind of bring in the tooling as well to provide that auditing and that rapid feedback to developers. So that's one area where we can, give that feedback really quickly. The other area that we talked about was admission control, and admission controllers run inside the Kubernetes cluster and will act as sort of the last mile of auditing your Kubernetes deployments to make sure that they are adhering to best practices. Now, it's typical today. A lot of organizations may not be leveraging an admission controller, but you can see that there are scenarios where deployments are entering the cluster, and there's a variety of just kind of warnings here around, hey, there's some best practices that we identify that probably should be followed. And we're going to allow this deployment in, but we're giving you some visibility around where some of these best practice violations may exist. But for our organization, we actually have configured some hard rules around making sure our deployments to certain namespaces don't have privilege escalation enabled. And we also require, a specific label as well, where we want to make sure all of our deployments are labeled correctly so that when they are deployed, we kind of know exactly who the app owner is and have some additional details for the platform administrator. So we were able to block this deployment around some of these policy violations. And so with Fairwinds Insights, you can configure both the CI/CD environment as well as the admission controller, and gain cluster level visibility into the risks that may exist. And over time, we can help organizations remediate and increase their overall Kubernetes health score so that they're showing progress against these types of items. The one final thing that we'll share here is we know that reliability and efficiency are really key. And so there's definitely scenarios where we can help, provide specific resource request and limit recommendations that ultimately translate into cost savings and help speed up the process of being able to figure out what should the memory and CPU profile of this application be. So that's a quick, 5-minute preview of our Fairwinds Insights software, which really can help organizations, adopt containers and Kubernetes technology across multiple teams and multiple clusters much faster. And if you're interested in learning more, we've got some great data sheet, white paper resources online, as well as the opportunity to request a more in-depth demo with our team. So with that, I think we'll turn it over to Dave to see if there's any questions from today's conversation.
Sure, thanks, Joe. Just a reminder to everybody, if you do have a question, please submit it through the Q&A panel in the lower right-hand corner of your screen. I do have a few questions that have already been queued up here. The first one is, are there any good tools for estimating or measuring reasonable resource limits?
Yeah, I'll let Robert jump into that one. Sorry about that, Robert.
No worries.
Yeah.
That's a great question. We actually have a project called Goldilocks, which is an open source project available on GitHub, github.com/fairwindsops/Goldilocks. Should pop up in a Google search too. Goldilocks meaning, you want to get your resource recommendations just right. You don't want them too high, you don't want them too low. What Goldilocks does is it monitors your actual application memory and CPU usage against what your resource limits and requests have been set to. And it tries to recommend something that's a little bit closer to what you're actually using. We also integrate Goldilocks into Insights. So some of the cost stuff that Joe was just showing uses Goldilocks data under the hood. We actually have a more sophisticated closed source offering there that utilizes Prometheus and gets some more fine-grained resource usage data, which can be a lot more helpful for spiky workloads. Goldilocks and sort of the more simpler solutions out there do really well for workloads that have very consistent memory and CPU usage. But for workloads that are a little bit spikier, it can be helpful to have very fine-grained data, which Insights can provide.
Okay, got another question here. It says, is there a recommended distro to use for container images in terms of one that tends to have the least known CVEs?
Yeah, really good question. So the general rule of thumb is the smaller the distro, the better. So I would not recommend using, say, like Ubuntu as your base image. Alpine is generally the image that we go with internally. It has just enough in that image that you can get done the most basic tasks that you're going to need to get done. It has a shell and all that. And there's a package manager to allow you to add on packages like curl or something like that if you need those inside your container. But the best thing to do, and something that we do where possible, is building your images from scratch, where you actually won't have any kind of base distribution. You'll need to really add in everything that you might need inside that container. It can be a real pain to actually do things from scratch because you're going to need to layer on a lot of base packages. It doesn't come with a shell or anything like that. So it can be a pain to work with images that are built from scratch, but they really are as pared down as you could possibly build a Docker image.
Okay, got two more. The next one is, are some of the security risks mentioned in the presentation pre-handled by a service provider, like managed services like GKE?
Yeah, that's a really common question, actually. Dave, would you be able to go back to slide 11?
Yeah, I can do that, Robert.
Oh, cool. Thanks, Joe. So the security issues that we talked about in this presentation are not handled by service providers like GKE. We mainly focused on these first two columns, container vulnerabilities and deployment configurations. Where GKE and EKS and AKS really can help you is in this right-hand column. They take care of a lot of the configuration of the like Kubernetes API itself. They can do some of this stuff. They, really with the kind of like the base configuration of Kubernetes, they can make sure you're doing things in a secure way, because they're gonna have a lot of those security things built in by default. They won't help you though with a couple of other things here, like risky RBAC profiles. You're still responsible for RBAC when you're running on GKE. You're still responsible for the add-ons like Nginx Ingress and certificate management and things like that. So there's still a lot you need to do on top of what GKE provides for you out of the box.
Okay. And last question. It says, does Insights work with air-gapped clusters that are not accessible from public internet?
Really good question. So we currently would need, some kind of allow list to allow the cluster to report back to Fairwinds Insights. We do have an on-premise version that's in beta that we could potentially work with you to work inside of an air-gapped environment.
Yeah, great question. I think it is definitely something that would be possible. We do have a lot of our customers on the software as a service environment, but we do have that self-hosted on-prem environment where we can work through some of those requirements. And I think that might actually answer the next question as well. So,
yeah. I got questions asking about URL to download the white paper. We're going to send a follow-up and we'll have a link for you to download the paper in there. And it looks like one more popped in. Is there any opinion on the TLS handoff at Ingress controller versus MTLS using service mesh?
Yeah, I think there's a trade-off there, right? And it's really between simplicity and security. If you put in a service mesh using MTLS, you're going to have an additional level of security. You're going to have additional level of control over which applications can talk to which applications. Sort of the vanilla out of the box configuration with Kubernetes is going to allow every workload in the cluster to talk to every other workload. Having a service mesh in place is going to let you pare that down a little bit, but it's also going to most likely cause headaches, in terms of your development teams being able to talk to the right services. Or having to configure those things. So it's really, I guess, it depends on your organization's appetite for security risk, on your organization's level of maturity. If you're just getting started with Kubernetes, you're a small scrappy startup, you're probably good with just kind of vanilla ingress. If you are more enterprisey, I would suggest going with the service mesh route and being, especially if you have a sort of multi-tenant cluster where you've got many teams that don't need to talk to each other, deploying to the same cluster. Getting a service mesh in there with MTLS is going to be helpful.
Okay, at this time, I don't see any further questions. Robert and Joe, any final thoughts, or should we just wrap up?
No, I think this was a great discussion today. I really thought the questions were great and relevant to today's content. And so, if anyone has any would like to get any more information about Fairwinds or how we can help, you know where to find us.
Yeah, thanks everybody.
Right. Thanks. That'll conclude today's session.